Dearmond here. We're going to be looking at the virtual lab, virtual specific heat lab. And as you look at this in eSimbler, you've already connected on the virtual lab instruction part 1, which is what we're looking at. So go ahead and download the virtual lab thermo. Open that. There it is. Now if you go to the very top of this file, you'll see the URL right here. That is the simulation that we'll be looking at. So I'll click on that. Try to click on that. There we go. There is the simulation. Now let's take a look at the instructions right here. It says choose 2 metals to work with from the menu. So you can choose anywhere from silver, gold, copper, iron, any of those 4 metals. The metal X and metal Y will be used in the second part. It says you will place a piece of warm metal in cool water in a calorimeter. The calorimeter is this device right here. It has perfect insulation, so no heat comes in or out, which is not true in a real lab. You would have some heat coming in or out. This is perfect insulation in this simulator. So it says to make a prediction of which metal will raise the temperature of the water the highest. So you'll pick 2 of these metals and write them right here, metal A, metal B, and then your prediction as to which one you think will raise the temperature the most. And then once you get your data here, then you'll answer these questions right down here. Make sure you get those. Now what I'm going to do is I'm going to do a sample here so you can see how to do this. You know, the first thing we'll do is I'll pick a metal. I'm going to pick gold, and then I'm going to, of course, increase. I'm going to increase the mass, but I'm going to increase the temperature as well. So I'm going to take the mass at 120 degrees and the temperature at 220 degrees C, leaving the water at 30 and the temperature of 20 degrees C. Now I'm going to go ahead and fill that information in right here on our on the lab itself. So there I have all the information filled out on the lab worksheet, and then I come over here to the simulation and push start. There we go. Now as it runs along, I'm going to get my form over here ready. I changed this to Word so I get a little bit more flexibility. But if you notice, as the temperature goes up, it continues to increase, and then it flattens out. Now it becomes a constant temperature. Now you say, a constant temperature, Dearmond? Well, look at this, how this changes around. Well, if you notice, what it's doing is just oscillating around a temperature. So it goes as high as 41.84 and 41.80. So I would take the average of that and write in here 41.82, because that's right in between 0.80 and 0.84. Okay, so that's all set. Now I need to work out my calculation right down here. It says calculate the heat that was exchanged by the water using this formula. Q is equal to MC delta T. Show all the steps and be sure to include units in all steps and in your answer. And be sure to indicate the sign, whether it's positive or negative. Okay, so let me get a pen over here to write with. Alright, so I'm going to write my equation here. Q is equal to MC delta T. That's Q is equal to the heat, and mass, M is mass, C is the specific delta T. Let's go ahead and identify those up here. Since we're working with water, I'm going to kind of make a line here, because right below this line is about water, above the line is about the metal, which we'll do a calculation in a moment. So here is the mass of the water, the temperature of the water initial, so I'm going to put T I, I'm going to put a W for water. This is the specific heat, which is capital C. And then the temperature final, this would be TF for the water. Now, by the way, this final temperature will not only be for the water, but it will also be for the metal. Because when you put the metal in the metal heats the water, and the water cools the metal. So they end up being exactly the same temperature. So this final temperature will be true for the metal and for the water. Now we'll put our data in here. So Q is going to be equal to the mass of the water, which is 30 grams. The specific heat is going to be 4.18, and that's joules per gram degree C, times my change in temperature. Well, I really don't have a change in temperature calculated, so let's calculate that. Change in temperature is going to be the final minus the initial. So that's going to be equal to the final, which is 41.82 degrees C, minus minus 20 degrees C. That was for my water, so it's going to come right down here. 20 degrees C. So I'm going to subtract those, and I end up with 21.82 degrees C, and that's what I'm going to put right down here. 21.82 degrees C. Now I have all those, and I'm ready to calculate. So I calculate those together, and I come up with 2,736. Now what units is that going to be? Well, since I have grams on the top, grams on the bottom, those cancel out. Since I have degree C on the bottom and degree C on the top, those cancel out. So I end up with only the units of joules. There we go. Now I want to look at my significant figures here. Let's go through our significant figures. That's 1, 2, 3, 4, 5. 5 significant figures, 5. Here's 3 significant figures, 1, 2, 3. Even though I'm not using these numbers, that's the same down here. There's only 3 significant figures in my specific heat. So that will limit how many significant figures I have. So I have 2,700, and so that's 3 significant figures, 1, 2, and 3. The 6 is going to change the 3 to a 4, so I'll end up with 2,704, and the last digit will be a 0, just a placekeeper. And that's joules, so that'll be my first calculation. That is the heat exchanged by the water. This is the heat into the water. Now the second calculation is the heat out of the metal. So we're going to be using this data over here along with the final temperature. I'm going to do this calculation right at the bottom here since I have room. Okay, so that same calculation, we'll use the same equation. Q is equal to calculation for the temperature is negative 178 degrees C. So I'm going to put that right down here and do my complete calculation. And that ends up to being negative 2736.8. And again, we're going to be using 3 significant digits due to the specific heat. So that would be 1, 2, and 3. So I'm going to end up with a negative 2,700. Now the 6 is going to make the 3 into a 4. 4 and a placekeeper 0 is going to be joules. Now let's compare these two numbers. They are exactly the same except one bit is negative. So the idea is the heat that goes into the water came out of the metal. So it's like it came out of the metal and then went into the water, and that makes complete sense because the heat, the water started off at 20 degrees. The only heat that increased the temperature of the water was the heat that came out of the metal. So you'd expect them to be the same, and that they are. Alright, so we have the two calculations, the comparison. Now you need to answer the question on the second page that asks about whether the law of conservation of energy is true or not. Then we'll move on to part 2.